Constituents of extracellular and intracellular fluids. Textbooks. Guyton and Hall. Textbook of Medical Physiology. 11th edition. Pages 469 to 482. Textbooks. Guyton and Hall. Textbook of Medical Physiology. A South Asian edition. 2013. Pages 309 to 482. Because the plasma and interstitial are separated only by highly permeable capillary membranes, their ionic composition is similar. The most important difference between these two compartments is the higher concentration of protein in the plasma. Because the capillaries have a low permeability to the plasma proteins, only small amounts of proteins are leaked into the interstitial spaces in most tissues. Because of the Donin effect, the concentration of positively charged ions, cations, is slightly greater, about 2%, in the plasma than in the interstitial. The plasma proteins have a net negative charge and, therefore, tend to bind cations, such as sodium and potassium ions, thus holding extra amounts of these cations in the plasma along with the plasma proteins. Conversely, negatively charged ions, anions, tend to have a slightly higher concentration in the interstitial compared with the plasma, because the negative charges of the plasma proteins repel the negatively charged anions. For practical purposes, however, the concentration of ions in the interstitial and in the plasma is considered to be about equal. Major cations and anions of the intracellular and extracellular ids. The concentrations of calcium ions and magnesium ions represent the sum of these two ions. The concentrations shown represent the total of free ions and complexed ions. Referring again to figure, one can see that the extracellular id, including the plasma and the interstitial id, contains large amounts of sodium and chloride ions, reasonably large amounts of bicarbonate ions, but only small quantities of potassium, calcium, magnesium phosphate, and organic acid ions. The composition of extracellular id is carefully regulated by various mechanisms but especially by the kidneys, as discussed later. This allows the cells to remain continually bathed in id that contains the proper concentration of electrolytes and nutrients for optimal cell function. Non-electrolytes of the plasma. The total osmolarity of each of the three compartments is about 300 milliosmol per liter, with the plasma being about 1 milliosmol per liter greater than that of the interstitial and intracellular ids. The slight difference between plasma and interstitial id is caused by the osmotic effects of the plasma proteins, which maintain about 20 mm mercury greater pressure in the capillaries than in the surrounding interstitial spaces.